Yes,
Hi.
hang on a sec. Hello, Cecilia.
Hi, nice to see you again. Thanks for
Yes,
taking
nice to see you
time.
too. Hello, Maria.
Hi, Ron. Good to see you again.
Ron, nice to see you.
Yeah, hello.
Yeah, so joining us today is Jason Villagomez. He's a marketing manager at Nanian.
Yes.
So it would be great if we could just start out with you just briefly telling us again about your project and your main objectives with the SURFE²R.
Yes. Yeah. All right. Well, the main thing that we're interested in is the interaction of the N-terminus with the membrane. So Maria asked last time about the lipid asymmetry. So the protein itself is asymmetric. Okay, so the N-terminus is going to be on one side of the membrane, and we think it comes down and interacts with the surface of the membrane via an electrostatic interaction. And there is a theory that's being put forward for peripheral membrane proteins that they are regulated by what's called an electrostatic switch mechanism, which means that there's this electrostatic interaction, and when a serine gets phosphorylated, puts a negative charge onto the N-terminus, and then that repels it away from the phosphated serines on the surface of the membrane. And when that happens, the protein comes off and goes off somewhere else in the cell, like to the nucleus, for example, and functions there somehow or other and does something. But for the sodium-potassium pump and HK ATPase, we think we have the same mechanism happening, but because it's an integral membrane protein, it's not going to go out of the membrane. It's still going to stay embedded in the membrane. But when the N-terminus comes off, that changes the activity of the protein. So we think that's very important in the regulation of the protein. And so the project is, so it's a fundamental research, really. It's not directly targeted at a particular disease, but maybe I'll talk about that in a minute. But in a bit more detail, what we're going to look at is this interaction with the membrane. And I've just jotted down a few points here, just to jog my memory. So there are, first of all, we need to know that we can measure the activity of the sodium-potassium ATPase and the proton pump that we get from the stomach. So we would take our membrane fragments, absorb them to the surface of the SURFE²R, and then activate with ATP and see if we can see some capacitive currents, first of all. And then we would add inhibitors to see if it goes, specific inhibitors, to show that the signal is really due to the proteins that we're trying to investigate. Then, so once we're sure of that, and we're pretty sure that's going to work because that's been done before. So Francesco has done it, Francesco Tadini in Florence has done it with the calcium ATPase, and Klaus Fendler has done it with the sodium-potassium ATPase in Frankfurt. So that's pretty sure that's going to work. Then the next thing is to focus on the N-terminus. So there is a conserved serine on the N-terminus that we think gets phosphorylated by protein kinase C. So what we would do is we would add protein kinase C, phosphorylate the serine to push the N-terminus off the membrane and see if we can see any change in the activity of the proteins after that. Then what we do, another experiment that we can do is we can specifically cut off the N-terminus. So if you add trypsin to the enzymes, that cleaves at a particular spot on the polypeptide sequence, and it cuts the N-terminus off. So then we could do the same experiment again, adding protein kinase C, and see if there is any effect on the protein when the N-terminus is gone. And so if the effect goes away, then we can conclude that it was coming from the N-terminus. Then the next thing would be take the N-truncated pumps, treat them with, well, we'd have to, I said I already, treat them with the protein kinase C, but we'd have to, first of all, check the truncated pumps as well to see if we can still see some activity there and see if if we can inhibit that with, so warbane in the case of the sodium potassium ATPase. So, and then the next step will be try it with the calcium ATPase. So the calcium ATPase doesn't have a long N-terminus, so it's very different from the sodium potassium ATPase and the proton pump in the stomach, because the calcium ATPase circa, that's in the sarcoplasmic reticulum, and the membrane that it's in is not asymmetric. It's only the plasma membrane, which is asymmetric. So we think that this N-terminus interaction is only important for the pumps that are present in the plasma membrane. Okay, so that's basically the project, and that's going to take us quite a few months to get through, I think, already. I think that's going to keep us busy for the time that we have the instrument. But I can go on, if you like, and talk about disease conditions. So yeah, all right. So if I just focus on cancer, okay, there are lots of diseases where the sodium potassium pump and HK ATPase and calcium ATPase are involved. But the cancer is very interesting because in cancer, you get a change in the lipid asymmetry. So normally, so if cells undergo apoptosis, when a cell undergoes apoptosis, the phosphatidylserine gets exposed on the outside, and that's a signal for macrophages to come in and dispose of the cell. But of course, that doesn't happen in cancer cells because they keep proliferating. I don't know how that is, how the cancer cells avoid being engulfed by the macrophages, and maybe no one knows that, but it's known that it does happen. So if the phosphatidylserine comes to the outside, then that means you're going to lose the interaction of the N-terminus, which is on the cytoplasmic side, and that will affect the activity of the sodium potassium ATPase. So then what happens is the cancer cells have to express, in order to survive, they have to increase their expression level of the sodium potassium ATPase. So you can potentially use the sodium potassium ATPase as a marker for a cancer cell. So you could possibly then, if you take a specific inhibitor like warbane, that's going to kill the cancer cells quicker than it will healthy cells. So of course, you don't want to put too much in because you don't want to inhibit all the sodium potassium pumps, but a small amount could potentially be beneficial in treatment of cancer. So that would be a long-term goal. But first of all, we would focus on the fundamental question of how the lipid asymmetry is important for the function of the pumps.
Yeah,
so
thank you.
That's about it, I think.
Yeah, thanks, Ron. Very exciting research, I must say, and also the perspective of a possible link to getting at cancerous cells.
Yeah.
So we have some exciting news for you.
Yes.
You have won the SURFE²R.
Thank you very much.
Yeah, we love the project. It's really great.
Yeah, well, that's great. Well, that's great news. So I'll sleep well tonight.
That's good. That's good. So I suppose, Maria, you and Ron will have to sort out the details of getting the surfer to Australia.
Yes.
Exactly. So yeah,
All
I
right.
will get in touch with you and we
Yes.
can discuss all the details and
Well,
timelines.
at the moment, we're still in lockdown.
Yeah, we
So
wait a
our
bit.
our lockdown has been extended now until the end of August, and it's possible that it may be extended again.
Yeah.
So it seems that the lockdown is not doing a lot of good. So now they're going to plan B and just trying to vaccinate as many people as possible.
Okay.
Yeah,
So
we can completely
we just have
accommodate
to
to.
keep our fingers crossed and press our thumbs that something works there.
Yes, for sure. We will. We hope the same here.
Yes.
No,
Well,
but
at least you have summer still, don't you?
sorry?
You're lucky that you have summer still
True.
in Germany.
Kind of summer. It's
Kind of
horribly
not a good
cold.
summer.
It's not a good summer, no, not at all. So are you going to work together with Francesco Tardini? Or
Yes.
did you?
Yes, I would like to. That will be very good news for Francesco as well. He wants to come out here and he wants to bring his whole family with him.
Great.
Excellent.
Yes.
Yeah, that's nice. Yeah, he will for sure.
So that would be great for me to work with him. Yeah.
Yeah. So do you already plan what you want to start with the sodium potassium pump maybe then?
Yes, I think.
Yeah,
I think we will start with the sodium potassium pump. Yeah.
Great.
Because that's the one that we have the most experience with.
Yeah. You already had the preparation, right? Or kind of. Yeah.
Yes.
No, this is.
No, I've been working on that for I don't know 20 years or something.
Okay. New perspective on an old protein for you.
That's right. Yeah.
Nice.
Yeah, but that's actually interesting. We have another winner, Edmund Kunti, with the same approach. I mean, it's a retake on an old project.
Yeah.
So.
Well, potentially that could be have a very good impact, a high impact, if it's already known to be a important system.
Yeah, it's true. And you don't start with zero, but maybe you can answer some questions that have been around for some time.
Yes.
And actually, I saw just a few days ago, Andre found a paper on asymmetric proteoliposomes and how to generate them.
Yeah.
So that is very exciting. So maybe that would also be something to
I think that would be good.
I
think that I think that would be a very good extension of the project.
Yeah. Great.
So I'll keep that in mind.
Yeah, I personally, I was not aware that this is possible at all. So I found it very interesting.
Yeah.
That one
Which
can do
group
that.
was that? Do you remember?
I can send you a link. It was in Biophysical Journal from Heiko Herklotz.
Yes.
Yeah.
I know. Yeah. I don't know him personally, but I've seen his work and I have been in contact with him.
Yeah.
He's the one. Last time I said he's in Freiburg.
Okay. Yeah. That's the one.
Yeah.
Great.
Cool. All right.
Then we will be in touch.
Yes. All right. So you have a nice day.
Thank you.
And I'll probably go and have a look at the Olympics now, see what's happening, see if we can win some more gold medals.
Yeah.
All right.
All right. Thank you very much.
Nice evening.
We're looking forward.
Bye-bye.
Bye.